Week 2, June 29th through July 5th. New NEW 14. Systems Elimination 3 with no multiplication. This is our third method of solving systems and our final method. So let's get started. So like I just mentioned, we are on our final method for solving systems. So like we talked about before, you'll notice that the directions have stayed pretty consistent throughout this. Solve by elimination, state the ordered pair solution. State the ordered pair solution will always be part of our directions, even if you don't see it, because anytime you are solving a system that has two equations, you will have an x, you will have a y, because it is a location on that graph, which even if you're not doing it by graphing, you are still finding an x and a y. 2 equations, 2 solutions, 3 equations, 3 solutions, 12 equations, 12 solutions, right? There are 3 methods. We had kind of listed this one. I hadn't given you the name of the third method because we hadn't talked about it yet, but here we are. The first method was graphing. The second method was substitution. The third method is elimination. Now, they're named because they sound, or they're named for exactly what they do. Graphing, you have to graph. Substitution, you have to substitute. Elimination, you actually have to eliminate. So you are eliminating one of the variables so that you can solve that way. Substitution, you are substituting one variable for another. And graphing, you are actually graphing the equations on a coordinate plane. So I swear that they teach you in this order because if they taught you elimination first, no one would learn the other 2 methods, because I believe it is by far the most efficient and probably I don't want to say easiest. I hesitate to say easiest because I think easiness is relative to people. What's easy for one person isn't necessarily easy for another person, but I would say it's probably the most algorithmic and like procedural. So, you learn a process and you can continually do the process for each problem. So with elimination, good news, bad news. So I just gave you the good news. It's, a process that you can learn. The bad news is on any quiz or test, they'll say, do this one by graphing, do this one by substitution, do this one by elimination. So even though now you know how to do elimination, it does not eliminate the fact that, no pun intended, you have to know how to do the other methods. So with that, given that, let's get started and I'll teach you elimination, and you yourself can decide which one you like best and which one you want to be able to use. Elimination relies on combining like terms and getting numbers and signs to match up. So you have to know that in order for things to, quote, cancel out, again, that word that I dislike, in order for things to zero out, if you think in terms of money, if you have a $5 bill and I take it, all right, in order for that to happen, we needed to not only have the same number, but we also had to have opposite signs, right? So in order for things to knock out or zero out, we had to have the same number but opposite signs. So if we look at number 1, okay, that will happen not with the x's but with the y's, because the y's have opposite signs. One's a positive and one's a negative, and there's a 1 in front of both of those, right? So I have, a 1 here and a 1 here. So if I were to draw a line underneath here and combine. Now, I'm not going to say add and I'm not going to say subtract. I'm going to literally say combine, because what you do depends on the signs of what is there. So if there's nothing there, you have to assume that it's positive. So that x is positive, that other x is positive. The only thing negative in this whole problem is the y on the bottom. So if I'm combining, and the other small thing to note is, in order for this to work, your x's, your y's, and your numbers have to be lined up vertically, right? So the first thing I'm going to check is this. Here's my x's lined up. Here's my y's lined up. Here's my numbers lined up. Now, usually we do it in that order. X's, y's, equal sign, and then numbers on the other side. That's like an etiquette thing. That's like a royal family thing. It just happens. It's been that way for so many hundreds of years that we just leave it. Okay? So, if I have an x and an x, that means carrying it down, I have 2 x's. If I have positive 1y and negative 1y, I have 0 y's. And there's really no point to writing 0y, because 0 times anything, 0 times y, just is 0, and that's a placeholder, which there's no point in writing it. And then I have the equal sign, which I have to drag down. And then I have 7 and 1, and 7 and 1 combined is 8. Notice that if this happens correctly, and I'm sorry to interrupt and kind of go off topic here. I'm getting kind of a wicked thunderstorm here. I'm outside in my sunroom, so you might be able to hear it. I hope it's not too distracting, but it's way louder inside my house where my kids are. So we'll see what transpires. If I've done this correctly, back to the math, one of my variables will eliminate on its own, and I can go about my merry way solving, because again, I can't do this solving for 2 variables at the same time. I have to get down to 1 variable. So I have 2x equals 8, and then I can divide both sides by 2. I get x equals 4. I'm already halfway done, probably more than halfway done. I put the 4 there for x in my ordered pair. And then I have to go back to one of my original equations, and I'm going to go back to the positive one just because I don't like messing around with negatives. X plus y equals 7. I plug the 4 plus y equals 7. I subtract 4 from both sides, and I get y equals 3. Plug that up here. Now, keep in mind, you can be checking your work for all of these, and you really should be. You can plug this ordered pair back into both of these and make sure that it checks out and you get the correct answer. And your sides balance and match. That's just good math, and you should do that. All right, let's look at number 2. You'll also notice, and this is just something that I do. Elimination is the only method that I write my ordered my systems on top of each other. For substitution, I actually write them next to each other, and for graphing, I write them next to each other. For elimination, I write them on top of each other because it lends itself to being able to solve itself easier. I'm probably going to pause myself for a minute, bring myself back inside, and get myself set up because I feel like it's getting loud. So pause. I'll be back in a sec, and we'll pick up from here. All right, we are back after a short pause, which turned into a long pause after a thunderstorm, a power outage, and yeah, about that. So we are picking up with number 2, elimination. We want to line up our X's and our Y's, draw our river for our equal sign, and then our constants, which are our numbers. What we need to happen is we need one of our variables to eliminate by having opposite signs, same numbers, and we do have that in the y's here. So the y's zero out because we have one positive, one negative, and we have 3's in both the first and the second equations. So then we combined, and when we combine, we get 4x and 1x, because if there's no number in front here, it's really a 1. So 4x and 1x gives us 5x. This is our 0 in our y column. And then negative 11 and 1, or 1 and negative 11, gives us negative 10. We divide both sides by 5, and we get x equals negative 2. Again, we're working towards that ordered pair, xy. X is negative 2, so that goes in that first slot. We need to plug the negative 2 into either the first or the second equation. Usually I try to pick either the equation that's more positive, smaller numbers, easier numbers, more positive numbers. It really, whatever one you prefer. So I'm going to plug it into the first one. So 4 times negative 2 plus 3y equals 1. That's negative 8 plus 3y equals 1. I'm going to add 8 to both sides. That zeroes out. I get 3y equals 9. I divide both sides by 3. And I get y equals 3. There's my river that ran all the way down. And that goes in that second slot. So my answer is negative 2, 3. I think that's it for that page. Yep. Let's go on to the next page. All right, number 3. Again, we're looking for opposite signs, same numbers. And again, if we don't have any coefficients in front, we can always place a 1 if need be, right? So I can place those 1s if I need to. Highlighting if I want to. Here's my x's. Here's my y's. Here's my constants. There's my river. I have, and you can kind of see where we don't have what we need in the x's, because the x's are both positive, because again, if you don't have a sign, they're both positive. And I have a 1x and a 3x. So obviously, if we're sitting here comparing, if you have $1 and I have $3, we do not have the same amount of money. But in the y's, we have 1 positive, 1 negative, so we have opposite signs, and we have 1 and 1, so we have the same amount. So that's where we want to go for the canceling. These zero out. Remember, 0 and cancel, we're using them synonymously. And then we want to combine. So 1x, 3x, that gives us 4x. Next column zeroes out. 6 and 10 gives me 16 because we're combining. We're not adding, we're not subtracting, we're not focusing on that. We are just doing exactly what it says. So if we have 6, we have 10, they're both positive. We put those together, we gather Think about hunting and gathering. We gather. So if there's 6 and there's 10, now there's 16. We divide both sides by 4. We have x equals 4. Working towards that ordered pair, x, y. X equals 4. It's x comma y. So that goes in our first slot, 4. I'm going to place this in my first equation because my first equation is pretty basic. X plus y equals 6. So it's 4 plus y equals 6. I subtract 4 from both sides. Those zero out and I get y equals 2. Place that in the second slot and my answer is 4, 2. All right, my last one for this. Draw my line underneath, draw my river going down, highlight my columns. There's my x's, there's my y's, there's my numbers. Place a 1 in front of any of the missing coefficients. All right. It's not going to be the x's that zero out because I have a 1 and a 3. My numbers are never going to be the ones that zero out because I'm looking to eliminate a variable. It is going to be the y's here because I have a positive and a negative, and I have a 1 and a 1. So these are the ones that zero out. And then I'm going to combine what I have. So with the x's, I have a -1 and then I have a -3. So if I owe somebody $1 and then I owe somebody $3 more, I'm still going to be owing them money, and I'm going to be owing them -4. So -4x. And again, with my constants or my number terms, I owe somebody $5 and then I owe somebody $3 more. I'm still owing them, and it's going to be -8. Divide both sides by -4 to get x alone, and I get x equals +2 because a negative divided by a negative is a positive. Working towards that ordered pair, answer, x comma y, the x is a 2. Again, plugging in, I'm going to plug into the top. I don't have to. I can plug into either, but that top equation on the last couple has been pretty basic and pretty simplistic. And again, this isn't make your life harder. This is work smarter, not harder. So I'm plugging in. Now, when I plug in this 2 into this equation, what the equation says is the opposite of x, or negative x. We can read this the opposite of x. So if x is 2 and it says the opposite of 2, this is actually going to be -2 plus y equals -5. So I'm going to add 2 to both sides. All right. When I add 2 to both sides, I zero that out. I get y equals -5 plus 2, which is still -3. That's going to be my answer for my y. So my final ordered pair answer is 2, -3. And I'm all done. Moving on to more elimination next. So I will see you soon.